Hi, I'm Amanda Blau from Corpus Christi Catholic School in Chambersburg, Pennsylvania, and this is NASA Now!
What that does on the asteroid,
the astronauts read out
the gravitational effect of those planets.
Hi, I'm Alicia. As more and more people choose to travel by air, the congestion at airports continues to grow and grow. So how can you put more planes in the air without creating major delays on the runways? Our expert today is working on an approach that could hold the answer. That's ahead, but first, here's what's happening at NASA Now.
An eye in the sky gives NASA a rare and up-close look at an active volcano. Studying volcanic activity can be dangerous for both researchers and aircraft. But recently, NASA flew 3 uncrewed Dragon Eye aerial vehicles over the Turrialba volcano in Costa Rica. The study launched 10 flights between March 11th and March 14th, 2013, into the volcanic plume and along the rim of the Turrialba summit crater, approximately 10,500 feet above sea level. Scientists believe this research will help us better understand how volcanic activity impacts our atmosphere, as well as to help improve NASA satellite data and aviation safety.
When conventional landings and takeoffs are not an option, NASA aerospace engineer Carl Russell and his colleagues step in to develop a possible solution. One is called a tilt rotor. Today they are used by the military, but in the near future you might find yourself as a passenger. Here's Carl to tell us why.
The main problem facing today's air transportation system is that we would like to add a significant number of aircraft to the system, but it's difficult to do this without adding delays. So NASA is looking at a bunch of different ways to increase what we call throughput, which is the number of aircraft that can fly through airports. One of the ways that we're looking at to do this is by adding rotorcraft. That's vertical takeoff aircraft such as helicopters and tilt rotors. Your typical helicopter can only fly about 200 knots. So we use these different configurations that can fly faster. Examples are compound helicopters, which use either wings for additional lift or propellers for additional propulsion. The other configuration that we're looking at a lot is a tilt rotor configuration, and that's like a V-22 or the Augusta-Westland 609. So a rotor can actually be thought of a rotary wing. In fact, that's what they're oftentimes called. The way that it generates lift is by spinning about its axis, and the rotor blades have a shape that is actually similar to a wing. It's called an airfoil. Now, when an airfoil flies through the air, it generates a force called lift. Now, on a wing, when the aircraft is flying through the air, the lift just acts in an upward direction. On a rotor, the lift acts in a direction that is parallel to the axis of the rotor. When designing a tilt rotor, engineers have to balance both hover and cruise performance. That is, we need to be able to take off efficiently, but also fly efficiently. And there are several trade-offs that engineers have to make when they actually create the designs. For example, the rotors are optimized for both cruise and for hover. They are smaller than you would ideally want to hover, and they are larger than you would ideally want for cruise. In addition, because all of the lift in hover is carried by the rotors, the wings have to be stronger. The tilt rotors that NASA is looking at right now hold around 90 passengers, and this would be similar to your typical regional jet that might fly about 1,000 miles. A tilt rotor the size of a regional jet is not currently flying, and no prototypes have been made. But the military is flying the V-22, and there are additional examples of tilt rotors that are flying. So the technology exists for tilt rotors, but one the size that we would use for passenger transport has not yet been built. There are many areas of future research in tilt rotor and high-speed rotorcraft technology. These include improving efficiency, improving safety, of course, reducing vibrations, improving handling qualities, and the list goes on and on. Eventually, if a prototype is made, additional issues will have to be worked out because, while design tools have improved a lot in recent years, it's still impossible to get everything right on the first try.
Our expert introduced us to a future concept in air travel. Now it's time for you to try your hand at aerospace design.
Teachers, you and your students can apply what you saw in today's program by working on creating your own airfoil. Look for Forces in Motion, the Great Boomerang Challenge. You'll find it under the Extensions activity on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer School.